All right, we're going to continue along here with some more video help and support for our lessons on exponential functions. Right now, we're going to look and see how we can determine if a function we're looking at exhibits exponential growth or exponential decay, and what percentage of growth or decay our situation would represent by information we can pull out of the function itself. So last time we learned that exponential functions are of this form right here, f of x equals a times b to the x. Right? Again, where, just a quick review here, a is our initial value. Right? That's our y value when the x equals 0. It's also, when we get to a point where we're graphing these, that's going to be our y-intercept. And b was our multiplier. That's what our table, last time we were looking at tables, what they're going to multiply by every single time. So if something's multiplied by 2 or 3 every time, that would be the multiplier. And x is the number of times multiplied. So really that's the x value from our table last time, or we could pick whatever x we want and plug in and figure out what our function would tell us. So that's kind of what we looked at last time. We're going to kind of continue this right now. I want to take a second, and we saw it just for a second in the last video yesterday, but I want to examine the multiplier here a little bit, because if we think about multiplication, right, what happens if I multiply something by 1? Right? If I have a number, we teach this in elementary school, right? When we learn our times tables, if I have a number and I multiply it by 1, it really doesn't change anything, right? 7 times 1 is still 7. 15 times 1 is still 15. But if we multiply by something larger than 1, our result gets bigger, our product gets bigger. If we multiply by less than 1, it's going to get smaller, right? If I take 7 and multiply by a half, it's going to be 3.5. It's going to be less than 7. So when we think of our multiplier, one thing we want to really take with us from today is if b, the multiplier, if that b, that number that's right there, is bigger than 1, that means that it's increasing. And my graph is going to look like something like this, right? It's going to go up from left to right. And if my b is less than 1, that means that my function is decreasing. Right? If I multiply by a number less than 1, it's going to get smaller. So that means whatever my function starts, I'm not sure exactly, it's going to go down and look like this. So it's going to go down from left to right. So that's important to recognize. We are not doing any graphing today, but we are going to have to look and see if the b is greater than 1, that means increasing, less than 1 means decreasing. If I ever see that the b equals 0, that actually, or excuse me, equals 1, that means that it's multiplying by 1. It's actually going to be a constant. It's not exponential at all. So we haven't really talked about that, but we're going to look and see increasing or decreasing. So that's kind of the notes portion. Let's kind of get into a few examples here and get you set up for some homework. So sometimes we'll think of our multiplier as a percentage, right? So before we get into that, let's just look here, 100%. If I'm thinking of how to write that as a decimal, right? Percent means divide by 100, right? You can even see here that's percent sign looks like a division sign with 2 zeros. You're going to divide by 100. You're going to divide and move the decimal to the left twice. So 100%, if I wanted to write that as a decimal, would be 1, right? I could put 1.00. That's 100%. 127% written as a decimal. 127%, I'm going to take the decimal and move it to the left 2 times, right? I'm going to have 1.27. And 87% written as a decimal, right? 87%, I'm going to take the decimal and move it to the left twice. So 0.87 is how I would write 87% as a decimal. So I'm bringing this up because that's going to be really what we're working on today, is we're going to look and see in our equations if the multiplier is bigger than 1, right? If this was our multiplier, this would be bigger than 1, and 0.87, if that's our multiplier, that's less than 1, right? So this case right here, I know I would have a function that's increasing. Problem with my pen here. Right, this means, my pen's not working, but there we go. This means decreasing, and this means increasing at the top. It's not letting me write there for some reason. So that's going to be important. That's what we're looking at right here. So example 1, what percentage is represented by the decimal 1.56? So if I think about the decimal 1.56, right, remember I moved the decimal to the left twice to get it from a percentage to just a decimal. I can move it to the right twice. This would be, so let's say 1.56 is the same thing as 156%. And you might be asking, why are we doing these? This doesn't have anything to do with exponentials, but you'll see in the next equation, we're going to see these types of numbers in our equation, and we have to be able to pull out this information. So examples 2 and 3, this is what we're going to have to be able to do on our homework right here. What percentage of growth and decay is shown in the following function? So remember, this is our initial value. Right, that's important, but we don't really need it for this to answer this question. What percentage of growth or decay is shown in the function? So all we're going to do is look at our multiplier. Right, this is our multiplier. If our multiplier is 1.12, that's the same as 112%. So now you can see why we're looking at those percentages. So it asked me what percentage of growth or decay is shown in the function. Well, if I start off a situation, I'm always going to start with 100%. I have 100% of my money, my car is worth 100% what I paid for it, whatever the situation is, right? 100% of the people we're trying to treat for coronavirus have the disease. We're always starting with 100%, and then we're going to examine, look at our multiplier and see what happened. So if our multiplier is 1.12 or 112%, that means our growth percentage is 12%. Right? It's 12 higher than 100%. And in our next video, we're going to look at, kind of a more formal way to do this, but this is just to get us started here. In example 3, what percentage of growth or decay is shown in the following function? So y equals 0.6 times 0.12 to the x power. So again, to determine growth or decay, all I need to look at is this right here. And I'm not really concerned about the initial value for this. I'm going to look at the multiplier and I'm going to ask myself, how much, well, actually, let's do it this way. First, let's just think of it, 0.12, right? That's 12%. Right, move the decimal to the right twice and I get 12%. So then I'm going to ask myself, how much above or below 100% am I? Or is it, or whatever you want to say, right? So this 12%, that's 88%. 88% below 100. So that means it went down 88%. So to answer the question, what percentage of growth or decay, right? Decay means goes down. So my decay percent is 88%. It's going down 88% every single time, every iteration, right? Every time my x goes up 1, my y is going down 88%, right? So that's pretty big. Okay, so those are some quick examples. All you're going to be asked to do for the assignment that goes with this particular set of notes here on Delta Math is to do exactly what we did in example 2 and example 3. You're going to look at that multiplier and convert it to a percentage, and then ask yourself, how much above or below 100% am I? If it's above, that means it grew. If it's below 100%, that means it decayed. And how much above or below is the percentage? Okay, so that should be enough to get you going on those.